Okay, guys. So let's get started with the session without any further ado. So again, in today's session, as I've mentioned already, we'll be talking about basic networking concepts. So this is one of the most important prerequisites required for people who are going to start into cybersecurity. So you need to know what basically networking is, what are IP addresses, what are IPv4, IPv6 addresses, and other few terminologies like subnet mask, DHCP protocol, DNS protocol. So all of this will be discussed in the networking concepts 101. Okay. So before we dive into, there's two important or very basic terms that you need to know. What is a host and what is a network? So basically, a host is an information device, an individual information device. So an example of it could be your laptop through which you're accessing this meeting, or your mobile phone, or your a smartwatch, okay, a router, again any device, any information device which is capable of transmitting data and receiving data. Okay, and when you have a collection of such devices, again, which can communicate with one another collectively, they are called as a network. Okay, so a network is a collection of information devices, okay, which in which each information device is called as a host. Now, just like how we talk to one another and we have our own identities, you can call me by my name, I can call you all respectively by yours. Similarly, devices also have names to identify each other, and that name is called as an IP address. Okay, IP stands for Internet Protocol Address. Okay, so this Internet Protocol was actually built by the US military in the late 1950s and 60s. There was IP version 1, IP version 2, and IP version 3. These did not work out successfully. What successfully rolled out to the public was the IPv4, IP version 4 address. Okay, and this is a 32-bit address. Now, what I mean by 32 bits is that it contains 32 zeros and ones like this. Okay, so basically computers talk on this language called binary language, and binary language contains only two numbers, either 0 or a 1. It's like off signal and on signal. Okay, now when you have 32 bits, you have consecutively 32 zeros and ones, and this 32-bit address is again divided into 4 equal parts. Okay, and each of this part is constituting of 8 bits each, and it is called as an octet or a byte. Okay, so this is the first octet, then you have the second octet, then the third octet, and the fourth octet, and each octet again is separated by a dot symbol. So as you can see over here, this is the dot. Okay, now what this is in the computer language. It's in the binary format. We humans can't understand binary that easily. What we usually understand is the decimal format, numbers from 0 to 9. So let's talk about how to convert this binary number to a decimal number, to a human readable format number. Okay, so before that, a quick revision on all the data formats in computers. So you have one bit which is equal to 0 or 1. When you combine 8 such bits, that becomes a byte, or it can also be called as an octet. When you combine 1024 bytes, that becomes a kilobyte. So this textpad file is usually in kilobytes. 1024 kilobytes becomes a megabyte. Your audio files or video files are in megabytes. 1024 megabytes becomes a gigabyte. Your hard disk drives or your movie files are in gigabytes. 1024 gigabytes becomes a terabyte. Again, same hard disk, external hard disks, and so on, so are terabytes. And finally, 1024 terabytes becomes a petabyte. Petabyte we usually never come across. This is usually used by the cloud organizations. Okay, so just a quick refresher on the bytes and the storage of data in computers. Now, coming back to this, converting a binary number to a decimal number. So I have the same IPv4 address here, again 32 bits of data. I'll take the first octet, okay, 10101010. Let's try to convert this number into decimal number. So I've written the same number down over here in an expanded format. Now to convert any binary number to a decimal number, there are two simple rules. Rule number one is you multiply the lower number with the top one. And on the lower, I've written down some numbers over here. So they're not random, guys. I've written down numbers from 2 power 0 to 2 to the power 7. Why specifically 2 to the power? Because this is binary language. You only have two possibilities, either 1 or 0. So one important mathematical rule, anything to the power 0 is always equal to 1. So 2 power 0 is 1. 2 power 1 is 2. 2 power 2 is 4. Okay, 2 into 2. 2 power 3 is 2 into 2 into 2. That's 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And finally, 2 power 7 is 128. Now, as I've mentioned, to convert any binary number to a decimal number, you multiply the lower number with the top one and keep on adding with the next. Okay, let me just draw this out as well, just a second, guys. Hmm. Okay, so as you can see over here, you need to multiply the lower number over here with the top one and multiply it with the next one. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. Okay, so I've written the same numbers over here, as you can see, 2 power 0 into 0 all the way up to 2 power 7 into 1. So anything into 0 is 0 itself. Okay, and anything into 1 is the value itself. So 2 power 1 into 1 is 2. 2 power 2 into 0 is 0. 2 power 3 into 1, that's 8. 2 power 4 into 0, that's 0. 2 power 5 into 1, that's 32 into 1, that's 32. 2 power 6 into 0, 0 again. And finally 2 power 7 into 1, that becomes 128. Okay, and if I calculate that out, 2 plus 8 plus 32 plus 128, you get the number 170. Okay, as simple as that. So what you see as 10101010 in binary language, the computer does not understand 170. It converts it to this number and reads it as such. Okay, this is clear, guys. Everyone, Amit, Basha, Naveen, Prakash, Sanjit.
Yeah, it's clear.
Yeah, it's
Right.
okay.
If this is clear, I have another number over here, 01011010. I would want you to calculate the answer for this and let me know if possible. Okay, again, same format, multiply the lower number with the top one and go with the next. So let me select all of this 1 second. Yes. So take your time, guys, no hurry. Do not make any errors and give me the answer. 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 all the way up to 2 power 7 into 0. Any answers, guys?
Hey, hi, Ahmed.
Hi, Carlos. Can you hear
Yeah, I
me?
joined a little bit late. What are we doing? I'm sorry.
Oh, we're just calculating, understanding how to convert a binary number to a decimal number. Okay, so I've given a basic formula. So if I have a number as such like 01011010, if you have to calculate it out, you just multiply these lower numbers with the top one and add it with the next one from right to left. Okay, again, we have numbers from 2 power 0 to 2 to the power 7. Okay, so 2 to the power in the sense, why? Because it's a binary number. So we have again all the numbers starting from 0 till 7. Okay, so I'm just waiting for the answer for the others from the others.
Oh, okay, got it.
I've got,
Okay.
okay, I've got one answer from Basha. It says 90. Let's wait for the other answers as well, guys. Any other answers, guys? Naveen, Prakash, Sanjeet, Amit Kumar. Okay, let's proceed further without waiting for any further answers. So again, 90 seems to be the correct answer, Basha. Well done. So again, if I just calculate this out and show it again, guys, just in case if you've missed it out. So firstly, multiply the lower number with the top one. Okay, so 2 power 0 into 0, that's 0. Then 2 power 1 into 1, that's 2. 2 power 2 into 0, that's 0. 2 power 3 into 1, that's 8. 2 power 4 into 1, that's 16. 2 power 5 into 0, that's 0. 2 power 6 into 1, 64. And finally 2 power 7 into 0, that's 0 again. Okay, and if I just calculate that out, 2 plus 8 plus 16 plus 64, that gives me 90, which is the correct answer. Okay, now again, just in case if you have made any errors, I hope it is corrected now with this explanation. Okay, now in a real-time scenario, guys, in an interview, you would never be asked like calculate any number from binary to decimal, but still it's very important for you to know so that you can understand the range of IP addresses. Okay, so now if I wanted to get the first IP address in the IPv4 range, all I have to do is put all zeros everywhere, because that's the very basic first possibility. And when I convert that from binary to decimal, that would just give me 0.0.0.0. Oh, sorry. Okay, and if you have to get the last IP in the IPv4 range, the only other possibility is putting all ones everywhere, because that's the maximum value you can get. Okay, so when you put all ones, it's going to be 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1 plus 2 power 4 into 1 plus 2 power 5 into 1, all the way up to 2 power 7 into 1. So that would be 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And if you just add it up, it's going to be 255 in total. Okay, so the last IP address in the IPv4 range will always be 255.255.255.255. Okay, so you'll never have a number in the negatives or a number above 255. So if you see an IP address like 300.150.20.6, this is an invalid IP address. No computer will ever accept this IPv4 address. Okay, so whatever numbers you have in the IPv4, they only range from 0 to 255. And how did we get that? From the binary to decimal conversion. Okay, now we know that this is the first IP and we know this is the last IP. What about the IPs in between? What is the sequence in that? We should start from right to left. Yeah, Prakash, we have to start from right to left. I hope that is clear. Okay, now proceeding further, as I've mentioned, we have to talk about the sequence of IPs. So I know this is the first one, this is the last one. What about the in-between ones? So in order to get the in-between IPs, we have a simple rule. Rule number one is always start with the rightmost value. So if this is the first IP 0000, next IP is going to be 0001. So the rightmost value will increment by 1. Next IP 0002. Next IP 0003. Next one 0004. Next 5. Next 6. Next 7, 8, 9, 10. All the way it goes up to 254 and then 255. Okay. Now after 255, will I have an IP like 000256? Is this a possibility? Definitely not. Okay, you will never have an IP above 255. So once the rightmost octet reaches the maximum value, only after the rightmost octet is completely filled, then go to the left value. Okay, and after going to the left value, reset the rightmost value back to 0. Okay, so this 255 becomes 0 and this left value 0 becomes 1. Okay, again, directly don't jump to after 0010. Don't jump to 0020. This is wrong. Okay, rule number one, always start with the rightmost value first. So after 0010, you have 11, then 12, then 13, then 14, 15, 16, up to 1255. Okay, ignore these numbers, guys, for the time being. This is just for an example to understand. Okay, I'll explain what this example is later. Okay, But for the time being, just ignore these right side numbers. Okay, only concentrate on the left side IP addresses. Okay, so 111213 up to 1255. Now this is again maximum. So this 1 now changes to 2. So you have 20, then 21, then 22, 23, 24, 25 up to 2255. Okay, and this repeats again and again and again. So 30 to 3255, then 40 to 4255. Okay, then 50 to 5255. Like that, similarly from 2550 to 255255. Okay, so whatever cycle repeated over here, guys. Okay, so from 00 over here, from the first IP 0000 to 00255 same cycle repeats again from 100 to 1255255. Same from 200 to 2255255. Again from 300 to 3255255. Finally, even from 25500 to 255 Now, similarly, whatever cycle repeated from 0000 to 0255 same cycle repeats again from 1000 to 1255 again from 2000 to 2255 finally from 255000 to 255. Okay, could be very confusing now, guys. Don't worry. Okay, you never have to remember this range, but this time I'm trying to show you what is the sequence of these IP addresses, and from this we can also calculate the total number of IPs. Okay, so each octet is repeating 255 times, guys. So the total number of IP addresses in the IPv4 range is 255 into 255 into 255 into 255. So from the first IP till the last IP, we have a total of 4.3 billion IP addresses. Okay, so this is the whole sequence of IPs, guys. Okay, again, you don't have to remember this range in any way, guys. I'm just trying to explain how many IPs we have. Okay, so each IPs or each octet is cycling 255 times. That again cycles with the next octet, again with the next octet, again with the next octet. That repeats from 0 to 255. Okay, so the total number of IPs are 255 to the power 4. Okay, so in total we have 4.3 billion IP addresses. Now my question to you is, are these IPs sufficient in today's world? So are the 4.3 billion IPs sufficient throughout the world?
No, sir.
Definitely not. Okay, because the population itself is close to 8 billion people. Okay, and each person again can have multiple devices. He can have a phone, he can have a laptop, he can have a smart TV, he can have a smart watch or a router or whatnot. Okay, so if each person itself has multiple devices and there's 7 billion people in the world, how would 4.3 billion IPs be sufficient? Okay, so in order to overcome that problem, guys, your IPv4 addresses again have two solutions for it. Solution number one is called NAT. NAT stands for Network Address Translation. So what they did was they translated or divided these 4.3 billion IPs into two categories. One is public IP, and then there's something called as private IPs. Secondly, when they know that this NAT solution also might not work, this could also cause a problem later on, then they came up with another IP addressing format, which is IPv6 addresses. Okay, and this is a 128-bit address. IPv4 is only 32 bits. IPv6 is 128. Okay, it's like 4 times the size. Okay, so we'll discuss IPv6 later on, but let's talk about public IPs and private IPs in today's class. Okay, so basically out of these 4.3 billion IPs, you have two categories, public and private, and these are again divided into 5 categories. Okay, so we'll discuss that in a bit, don't worry, but let's define these public and private IPs. So first you have public IP. This is the IP provided by the ISP. ISP stands for Internet Service Provider. Okay, so bodies like Airtel, Tata Docomo, or Act Hibernate or Hathway, all these people are called as internet service providers. They give you the service of internet. They provide you the service of internet, and that is nothing but with the help of something called as a public IP. So if you have a Wi-Fi router at your home, that Wi-Fi router is getting a line from outside, a cable from outside your house. That cable is from the ISP, and that carries the public IP for you. If you do not have that public IP, you cannot access the internet. And inside, in the other side of the router, you have your local devices which are connected to the router, your phone, your laptop, and so on and so. Okay. Each of these devices also requires an identity. So in the local network, not on the internet, but in the intranet, in the local network, each device gets a private IP. Okay, so this IP can be given by the router, which is also your DHCP server, or it can also be given manually by yourself, okay, or the network admin. So if I just draw this out, 1 second, to show you where we receive public and private IPs. Let us say this is my router over here, okay, and my router is getting a line from the ISP. Okay, so the ISP will provide a public IP. So this is the public IP part. Okay, it could be something like, let's say, random 1.2.3.4. Okay, and your router internally is connected to many devices. It could be my laptop, my phone, my smart TV, my watch, whatnot. Okay, and each of these devices is connected to the router internally, and they get something called as a private IP. Okay, so these devices are getting private IPs. So this is the intranet and this is the internet. Okay, is this clear, guys? Any questions or doubts up to this part? So this part is your intranet. Okay, and then the other part is your internet. Let me draw this other part out. This is your internet.
So
Okay.
this IP is assigned by the manufacturer or the network provider?
No, if you're talking about public IP, that is given by the ISP, Internet Service Provider. If you're talking about the private IP, you can assign it yourself, okay? Or you can make the DHCP server assign it. Basically, in your home network, your router itself acts as the DHCP server. So either your router can assign it automatically, or you can assign it manually yourself, okay? That is for the private IP. Public IP, that is given by the Internet Service Provider. Is that clear, Prakash?
Yes.
Right.
Yes.
Naveen, Basha, Carlos, Sanjeet, Amit, any questions or doubts up to this part?
No, sir.
Basha, were you saying something? Your voice was not audible.
Yeah, no, sir.
No, sir. It's clear.
Right. Now proceeding further, let's see this IPs practically now. So if I want to check my public IP, I just need to go to the browser, and in the browser I can search for what is my IP address. So I can just go to the browser, search for what is my IP, and if you hit enter, you can see this is my public IP at the moment. If I click on any of these websites, let's say what is my IP address.com, this will show me the ISP as well. So right now I'm taking up the session from Andhra Pradesh, okay, in India, and my ISP is Beam Telecom, basically Act 500, and they are providing me this IP address. This is the public IP. If you want to check your private IP, you have to go to something called as the command prompt. So just open up something for COMMAND command prompt. Click on the first link and just search for the command called ipconfig, which in short is for IP configurations. Hit enter, and right now I'm connected to my Wi-Fi, as you can see here. Okay, now so I have to check for my Wi-Fi interface, my wireless interface, and for my Wi-Fi adapter, as you can see, I'm getting the IP address as 192.168.0.3. This is my private IP, and this here is my public IP. Okay, so again, I'll explain why these specific numbers and why not anything else in a bit. Don't worry. Okay, so again, if you remember, I've told you there are 5 different categories as well. Okay, so there's a smaller category, public and private, but there's another category called classes. Okay, if I just divide this out, let me show you. So let's say this whole big box constitutes the IPv4 addresses. So IPv4 addresses, and they are in total of 4.3 billion IPs. This big box is now divided into 5 categories, and each of these categories is called as a class. Class A, B, C, and then D and E. Okay, so sorry for the terrible drawings. This is A, this is B, and there's C over here. Then there's D and E. Okay, and again, each class is subcategorized into public and private. So in class A, there's public and private IPs. Similarly in B as well, and similarly in C as well. But in D and E, there are no private IPs. All of them are public. So there's public and private. Similarly, over here also public and private. Similarly, public, and private. But in class D and class E, there are no private IPs. There's only public IP addresses. Okay, so if anyone needs to take a screenshot also, you can just take an image or a screenshot of this image just to understand the classification. Okay, so this is basically how your IP addresses are divided. We know what public and private IPs are. We'll discuss what these classes are in tomorrow's class. Okay, or in tomorrow's session. Okay, so but let me give the ranges now for each class. Let me clear this drawing. Can I remove the drawing, guys? Can I erase it?
Yes, sir.
Sure.
Yes.
Yes, sir.
1 second. Yep, done. So now coming back to this, there's class A, B, C, D, and E. As I've mentioned, class A starts at the first IP 0000, and class E ends at the last IP 255, 255, 255, 255, as you can see. So class A starts at 0 and goes all the way up to 127, 255, 255, 255. Now this is completely filled. So the next class starts at 128. This is ending at 127. So obviously class B starts at 128. Now from 128 it goes up to 191. Since it is ending at 191, class C starts at 192. Okay. From 192 it goes to 223. Then finally from class D it starts from 224 to 239. And lastly, class E starts at 240 to 255. So it's important that you remember these four numbers, guys. Okay, 127, 191, 223, and 239. If you remember these four numbers, you can get the next ones automatically. So class A starts at 0000, goes up to 127, 255, 255, 255. So one more trick again, another tip to remember: on left side you have all zeros, on right side you have all 255s, on right side you have all odd numbers, on left side you have all even numbers. Okay, 0 to 127, 128 to 191, 192 to 223, 224 to 239, and 240 to 255. These are the classes. Again, in each class, there's public and private IPs. So for class A, between 0 and 127, there's a small range, 10,000 to 10,255, 255, 255. This is the private IP range in class A. Any IP outside this range, by default, is a public IP, guys. That is very important to note. So this is the private IP range. Any IP outside that in class A is a public IP. Similarly, class B also, 128 to 191. In between this range, there's a small range, 170 to 1600 to 170 to 31, 255, 255. This is the private IP range in class B. Any IP outside this range is a public IP. Similarly, class C also, between 192 and 223, there's a small range, 192, 16800 to 192, 168, 255, 255. This is the private IP range in class C. Any IP outside this is a public IP. In class D and class E, there are no private IPs. All of them are public. So again, guys, you have to remember this 8 lines of data. This has been fixed by the people who invented IP addresses, and this is going to remain constant. It will never change for the rest of eternity. Okay, or as long as IPv4 addresses exist. Okay, so again, if I show you the very basic example, if you remember, I've told you class A starts from 0000 and ends at 127, 255, 255, 255. Now in between class A, there's a small range from 10,000 to 10,255, 255, 255. This is the private IP range. Any IP outside this range is the public IP. So from 0 to 9, this is the first public IP range. And after that, there's private IPs. After 10, there's 11. So from 11 to 127, this is again public IP. Okay, so I hope this explains the classification. But again, this repeats for same every class A, B, and C. This is clear, guys? Everyone? Carlos, Basha, Naveen, Prakash.
Yes, sir.
Private IP we can give on ourselves, so we can give any number, right?
Yeah, definitely. You can give any number in these private IP ranges, which I've mentioned over here. Okay, class A or B or C. You can assign any IP of your choice.
Try to assign other IP, it will give error.
Sorry, please come again.
Try to assign other than these range, it will give us any error.
It will not assign that IP in the first place. It will not accept it. Okay, so it will definitely throw an error. Okay, right. Coming back to this now, guys. So what I'm going to do now is one last exercise to end up the session. What I'm going to do is I'm going to write down 10 random IPs, guys. You have to look at these ranges and tell me whether they are which class they belong to, and whether they are public or private IPs. Is that clear, guys? So let me just write down 10 random IPs first. Uh, okay. Okay. So I want you to look at each of these IP addresses, guys, and then tell me which class they belong to first, and then whether they are public or private IPs. Okay. So first IP, which is
Class A.
10.2.3.10. Yeah, perfect. Class A. And public or private?
Private.
Perfect answer. Why private? Because this is between this range 10.0.0.0 and 10.255.255.255. Okay. Next IP, guys, 192.169.1.2.
Private.
Class C.
G.
Class C. Perfect. It's in this range. Perfect. Public or private?
Private.
Private.
Are you sure private?
Yes, sir.
Public.
Again, if you notice, this is 192.169.1.2. And IP over here in private range is 192.1.0.0 to 168.255.255. This
Okay,
is
okay.
169, which is falling outside that range.
Public IP. Public
Okay.
IP.
Okay. Just a second, guys. Give me 2 minutes. I'm getting a call from the institute itself. I'll be on mute for a minute. Just figure out the answers
Okay.
and let me know once I'm back. Okay, just give me 2 minutes. Okay, hello guys. Can you hear me? Am I audible?
Yes.
Right, perfect. Coming to the next IP, 172.35.10.35. Any answers?
B public.
Class B, public.
Public.
Are you sure?
Yeah.
Right, public itself. Don't get confused, guys. I might try to confuse you. Next IP, class.
Class C private.
Perfect answer. Next,
Class D public.
class B. Are you sure?
D.
D. Okay, public. Now, 1 second.
Next one is class A.
1 second, guys. Let me just arrange this up real quick. Right. This is class A. Perfect.
Private.
Private. Are you sure?
Yeah, sir.
How many of you say private?
Sorry, it's public.
Public IP. Okay, because this is 5 dot something. In
Yeah,
private, you only have
public.
from 10 to 10.
Mm.
Next one.
Next one is class B.
Class D. Are you
Private.
sure?
B.
Okay, B for Bombay. Okay.
Yeah. Private.
Public or private. Okay.
Private.
Next one.
Class
Which
C.
class?
C.
Class C. Private. Are you sure?
Yeah. A class C public. Private also. Public.
Public. Okay, because it is 192, 180.
Yeah.
180 is outside 168. So therefore it's a public IP. Next one.
Next one is class B public.
Public IP. Perfect. Next one.
Last one is class E public.
Class E. Public. Okay, perfect. This is clear for everyone, guys. I've received answers from only a few certain voices, not from all. I hope it is clear for Carlos, Basha, Naveen. Prakash, you answered, I guess, a few, and
Yeah.
Sanjeev.
Yeah, sure. Clear.
Right. Okay. So yeah, that's that, guys. Again, we have learned about these different ranges. Okay, we have learned what public IPs are, what private IPs are, and we have not discussed what classes are. I've only given the ranges for them in today's class. Okay, you've classified them. One last thing, let me show this practically as well. So I will go to my browser. If you notice over here, I've got a number 49.204.238.138. Which class and whether it's public or private? Can anyone let me know?
49.204.
Class A.
Class A.
Nice. Public.
Public. If you notice, this is my browser. In the browser, I can only see my public IP. Okay, so this is my public address. And if I go to my terminal, my command prompt, and if I check for my IP address, I've got an IP over here, something as 192.168.0.3. Can anyone tell me whether it's public or private?
Private.
Class C.
Private address.
Is
Class C and private address, as you can see, between 192.168.0.0 and 255.255. So command prompt shows your private IP and the browser shows you public IP. That's what you have seen until now, right? So I hope this is clear for everyone. So we have only discussed up to the different classes and what is again public and private IP and the classification or the conversion from binary to decimal. So in tomorrow's class, we're going to be going into much more advanced concepts, such as what are these classes? Why do we have different classes? What is the necessity for it? Okay, and then something called as subnet mask. We learn what subnet mask is. Okay, and then also we learn about DHCP protocol and DNS protocol. Okay, so a few more advanced concepts in network. Okay, so a bit more complex compared to today's class. So please go through this class notes, guys. I'll be sharing this notepad file with you all. So please send me your email addresses in the chat box so that I can share this notepad file with you guys. And when time comes, please go through it and let me know if you have any queries.
Sure. If someone want to access our laptop, do they need to know public IP or private IP?
Again, frankly speaking, Prakash, in today's world, you don't even need the IP address to access the laptop. All I need to do is send you an exe file, and through that exe file, I can remotely connect you. Just like the example of TeamViewer. So for TeamViewer, you require a password and then the user ID to connect. But if I send you an exe file, a very small 1 MB, 2 MB exe file, if you just double click on it, automatically your system will connect back to my IP address. So in that scenario, I don't even need to know what your IP address is. Okay. So, but the connection will happen on public IPs only.
When you take the remote connection, right? Some other people remote connection.
Yeah.
Sometimes sometimes in office we take the remote connection, so we give the IP address.
Exactly. That's the public IP over there. That's the public IP. Exactly. Hello.
Okay.
Right, that's always the public IP. So whenever it's one important point to remember over here, Prakash, if it's a connection over the internet, it will always involve public IP. If it's a connection in the local network, so from your computer to another computer in the same network, in your local intranet network, then only private IP is necessary. Okay, so that's an important tip to remember.
Okay.
Okay, right. So please share me your email addresses, guys, in the chat box so that I can share the notepad document. Right, I've got a few. The skills are required to learn this course. Naveen, again, as I've mentioned, we need to learn networking concepts and virtualization and Linux commands. So all these skills are already included in the course. So you don't need to learn them from somewhere else. Okay, they're included as prerequisites in the course itself. But
Is
again,
it a
just to answer
class?
the question, this is the first class.
Okay, okay.
Mhm.
Sorry, in intranet there is public IP. It can we work or not?
In intranet, you only require a private IP. You do not need a public IP, Sanjay.
Sure. When we have no internet connection, that will be working or not?
Again, if you want the internet connection to work, you need a public IP. If you don't need an internet connection, you just have an intranet, a local network, and you want devices to communicate with one another, then private IP is
Yes,
sufficient for that.
yes, sufficient. But work is work. Internet connection is working on public IP also when internet is off.
Sorry, I didn't get your question.
When internet connection is off, public IP work as an intranet or not?
It will not. Why will public IP work on the intranet if the internet is off? If the internet is off, you won't get a public IP at all. You will only have the private IPs. Okay.
Okay, okay.
Oh, sorry. So I've attached the file, guys. I've got 5 email addresses over here. Am I missing out on any other email? I hope I've got all of them. Oh, there's another one. One second. Yeah, I guess I have all the email addresses here. Please let me know if I'm missing out on anything, guys. Right. So I've sent the email. Please go through the notepad file, and if time permits, go through the advanced concepts as well. If not, we'll discuss them anyhow at tomorrow's class. Okay. So yeah, that's that, guys. Nothing further. I'll exit the session. I'll see you tomorrow at the same time. Bye-bye.
Sir, we have to register again, once again, or the link will come on that mail ID.
Sorry, please come again.
We have to register one again on that link provided by DurgaSoft.
Yeah, for this week you have to register, Amit. From next week onwards, you'll be getting a new link on once the payments are done. And for that link, you don't have to register anymore. You can directly join. So once all the payments have been confirmed, we'll send a new link for all the students.
Okay.
Okay, sure. So yeah, that's it, guys. Good night. I'll see you tomorrow. Bye bye.
Thank you. Thank you. Thank you, sir. Good night.
Thank you, guys. Bye.